All right, last video of the school year. Let's get through this, then you'll be ready to quiz on Tuesday. Um, Wednesday, if I see you, that's great. Thursday is the half day. Many of you probably won't be there, that's okay, but to all of y'all, have a great summer. After this, of course, first you got to buckle down, learn this material. But I feel like you learned it. I really feel like you guys were doing great in class, and so hopefully this won't seem bad, but let's just get into it without further ado. So looking here, we talked about how um, for every function, um, there's something called the antiderivative. And the antiderivative of a function, let's say this function that they gave us was called f of x, then the antiderivative of f of x is something that we typically denote with the same letter but uppercase. And the way the antiderivative works is the antiderivative should be the guy where if you took the derivative of capital F, the result would be lowercase f. So it's like we've done derivatives. We know how to go in this direction to find the derivative of a function. This time we're trying to kind of go in reverse. We're trying to find the function that would give us the derivative. So antiderivative, kind of a perfect name. The antiderivative basically gives you what your integral is. So how do we do that? We said there's rules, and the rules are just kind of the reversal. They just reverse the rules of differentiation, and you apply them in the reverse order. So we did that on the notes. We said if you were gonna do a derivative, imagine if you had 5x cubed. Then the first thing you do is you multiply the coefficient by the exponent. Then the next thing we did was subtract 1 from the exponent. And by doing that, we landed on 15x squared. So now imagine if we were going the other way. If you started with 15x squared, then the first thing you'd want to do is, well, we'll do the opposite of step 2 first, which would be add 1 to the exponent. So we're now looking at, well, this thing's quadratic. The antiderivative would have to be a cubic, because we know that when you differentiate, degree goes down. So when you anti-differentiate, the degree must go up. Now the next step was, this was the only thing that's even remotely tricky, but if we were doing the antiderivative of this guy that had a coefficient of 15, you kind of keep that coefficient of 15, but obviously 3 times 15 would get us 45 now. I don't want a coefficient of 45. So that's why in step 2, we multiply by the exponent. Well, the reverse of that is divide by the exponent, but I don't like division. So let's multiply by reciprocal f, the exponent, which means the new exponent, by the way. So not the 2 that we started with, but after adding the 1 and getting to 3, we'd want a factor of 1/3 here. And then you can simplify. 1/3 of 15 would be 5. So according to those rules, 5x cubed would be our antiderivative. And the great news here is it's so easy to check this. You just differentiate and see if you get back 15x squared. And of course we do. So that's the process of doing an antiderivative. Now, we don't want you to just do an antiderivative here, though. We want you to actually do a definite integral. And a definite integral is not just an expression. You don't just land on some hunk of algebra anymore. You're supposed to land on an actual answer, a numerical value. So 2x plus 4 would be some line that behaves something like this. So when they say they want the definite integral that goes from 0 to 4, they're actually after the area that goes from 0 out to 4. They want this hunk of area. And to find that area, they said to apply the fundamental theorem of calculus. And the fundamental theorem of calculus says that the integral that goes from 0 to 4 for some function f of x, I'm going to do it sort of weirdly. But if we were going to calculate this, we would just find our antiderivative f and would plug in the 4. Then would subtract from that the antiderivative of f evaluated at 0. But that's it. You just kind of plug in those numbers, subtract, and the number that you get out is your area. So I know I said without further ado already, but I'll say it again. So without further ado, let's do this problem. my antiderivative would first be an x to the power of 2 term. Now I want a coefficient of 2, so I'll keep the 2. If I multiply by the reciprocal, I get 1/2. And if you practice this enough, it'll be pretty obvious to you that we just didn't want any coefficient here at all, because now when we differentiate, we'll multiply by 2, getting the 2 we want. We'll drop the power by 1, getting the 1 that we want. So that term's squared away. Now for the 4 is technically 4 times x to the 0, right? So this term would be an x term, and I want a coefficient of 4, and my exponent is 1. So 1 times 4 is 4, so that's it. Now the weird thing we said before about antiderivatives is there could always be some constant on the end. Imagine if I had a 117 here. Well, the derivative of 117 would make 0, right? There's always sort of room for a constant in your antiderivative, because the derivative of a constant is 0, which wouldn't affect that. So the way that we represented that was to always say, when we're done doing an antiderivative, that our function also has a plus c on the end. Now the good news again with the plus c was, when I go to apply the fundamental theorem of calculus, I'm going to plug 4 into this, right? So I know this integral is going to be an x squared plus 4x. Let's say we include the plus c. Then we use this funny vertical line notation to show that we're going to now evaluate this at 4 and then evaluate this at 0 and subtract. We'd be getting 4 squared plus 4 times 4 plus c. C is just some number. There's nowhere to substitute the 4. C is just some value I don't know. But as I now subtract what I get at 0, I'm going to get 0 squared plus 4 times 0, and then still plus c. Well, those two c's are always going to be the same. I don't even know what c is, but I know that whatever c was for this first incarnation of my antiderivative that I plugged 4 into, it has to still be the same thing. And we're always subtracting. Fundamental theorem of calculus says it's always a difference. So those c's will always cancel out. So for our purposes, when we're doing one of these definite integrals, you can ignore the plus c and it'll be fine. So what am I getting here? It looks like I'm getting a 16 plus a 16. And over here I'm getting a 0 plus a 0. So that's feeling a lot like a 32 minus 0, which is 32. And that feels fine to me, because at least for my sketch I was expecting a positive chunk of area, and I got 32. So the other thing that's great here is not only can you check your answer with your calculator, but it is recommended that you do. In fact, they insist that you do on the homework. It says do it, use a calculator. So I'll do it. I'll run through the steps again just to show you, even though I think you're probably all squared away on this. So I'm going to turn it on, slide it over. Slide it over. Alright, so again, what do? We go to y equals and we enter the function, which is 2x plus 4. Then you don't even need to hit graph. Just go straight to second calc and press 7. And our limits are 0 and 4. So enter 0, press enter. Type in the 4, press enter. You should see a piece of area get highlighted. It says the area is 32, and 32 is what we got. So I'm feeling great about that, and I'm moving on to number 2. And by the way, I will of course go much faster. As I went through number 1, I explained all the background knowledge about the steps and the blah blah blah. We can start cruising now though. Unless we bump into sine. Sine might slow us down, but I don't think it will. Think of it like this. You guys know that the derivative of cosine is sine. And shouldn't that mean that the integral of sine is cosine? Again, that's just demonstrating that inverse relationship, right? If the derivative of cosine gives sine, then the integral of sine must give cosine, and it does. So that means I can attack this problem now. I want this integral. So what's my antiderivative? Well, the antiderivative of sine, we just said, is cosine. And the antiderivative of x, well, it's got to be an x squared times the reciprocal, so a coefficient of 1/2. Yep, that'll do it. So this function right here is our antiderivative. And to find the area, we'll evaluate this at pi over 2. And we'll evaluate it at 0, and we'll subtract. So the value of this definite integral must be the cosine of pi over 2 minus 1/2 of pi over 2 squared. That's going to be ugly. I know I tell you guys often not to use decimals. This will be ugly. Not so bad, but again, resist that urge to use decimals. All right, then we're going to plug in the 0. So we get cosine of 0 minus 1/2 of 0 squared. Okay, so start evaluating. If you guys forget your cosine and sine values, draw yourself a unit circle. Pi over 2 is 90 degrees. I'd like to think you guys remember that. And cosine is the x-coordinate, so cosine of pi over 2 is 0. So that's a 0. Then it's a 0 minus pi squared over 4 times 2 would be pi squared over 8. Now the pi is squared, the 8 isn't, so don't put parentheses or nothing. All right, but there's my first half of the problem. Second half of the problem, cosine of 0. Well, 0, of course, is just right here on the x-axis. And if cosine is the x, then that's going to be 1. So this time around, cosine of 0 is 1. And obviously 0 squared times a half, that's just going to be 0. So it looks like we're looking at negative pi squared over 8 minus 1. And since these both have negatives on it, you know I don't like that. So I would factor out a negative and call this positive pi squared over 8 plus 1. It's just sort of standard practice to factor out a negative if both terms are negative. And so now instead we're thinking of this as, well, it's a pi squared over 8 plus 1, and then you just take the opposite of whatever that value turns out to be. So let's double check this. What is pi squared, by the way? Wouldn't it be like 9-ish? Divided by 8 is 1-ish. Plus 1 is 2-ish. Times negative 1 or whatever should be negative 2-ish. Why do I do all that? Well, because we're supposed to check this on our calculator. So bringing that guy back, clearing, going to y equals, entering the function, it's sine of x minus x. And before I do anything, I'll just double check. I am in radian mode, which is good because pi over 2 is pretty obviously radians. But now what do? I go to second calc, option 7. That's a funny looking function, but we're going to go from 0 to pi over 2. So just entering it just like that, we see a little shaded area. We see negative 0.2. That makes me nervous that I've screwed up. So let me double check this off camera, and maybe I'll come back and tell you I screwed up. Okay, yeah, so of course I'm a fool. And hopefully you guys were yelling at the screen this whole time. But, I mean, way back at the very beginning when I said the derivative of cosine was sine, that was always a lie. Derivative of cosine was negative sine, of course, which means the antiderivative of sine would not be cosine, because the derivative of cosine would be negative sine. So the derivative of sine is negative cosine, which doesn't change a hell of a lot, honestly. It just means now this would be negative cosine, blah, blah, blah. So this would be negative, this would be negative. I say it doesn't change that much because negative 0 is still 0. So this guy is still negative pi squared over 8. But over here, obviously, the opposite of the cosine of 0 would be negative 1, which means instead of subtracting 1, I'm adding 1, which means I can actually express my answer differently. It's actually going to be 1 minus pi squared over 8. Okay, so reevaluating this looks like a 1 minus, we said this was 9-ish divided by 8, so this is 1 minus 1-ish. So that's going to equal negative 0 point something. So there, that's me eyeballing my answer now and feeling much better about what we got on the calculator, because when we did this on the calculator said the answer was 0 point something, negative 0 point something to be exact. Enter, oops, let me do this again. 7, 0, pi over 2. Okay. Anyway, there's your answer. The negative 0.2337. And again, if you don't believe me, I know you may have lost a little faith in me, but 1 minus, if we now do pi squared over 8, it'll be the same number. Negative 2.337. So we know we're good. This is now the correct answer. By the way, when I say this is now the correct answer, I mean this expression, not the decimal. So the 1 minus pi squared over 8 would be the answer that I'm looking for. And I said we were going to go faster. We didn't really go faster. That's my fault. I'll try to go faster this time. All right, so let's hit 3. Great. Bonk. So 3 is kind of a straightforward polynomial. Hopefully finding the antiderivative is a piece of cake. For the 6x squared, we know the first thing we would do is raise the power from x squared to x cubed. Then think about it. You want a 6. Wouldn't you just put a 2 here? And now 2 times 3 makes 6. So that's what I mean about how you should be able to do this in your head. If you're not super comfortable doing it in your head, then just bring the coefficient with you, 6. And the other part of our rule was always multiply by the coefficient, the reciprocal of our new exponent. So you'd put a factor of a third here, and a third of 6 is 2. So 2x cubed is for sure the antiderivative of 6x squared. So we're good. Same thing with this 8. This 8 is technically the coefficient on an x to the 0. So if you raise the power of x to the 0, you get x. And then you want the 8. And the reciprocal of x to the 1, well, that's a 1. So 8 times 1 stays 8. So the antiderivative of the second term is for sure just 8x. And that's it. We've got our antiderivative. We want to evaluate that from negative 1 to 3. And that means substituting in 3. So you get 2 times a 3, that is cubed, minus 8 times 3. Now that's only the first bit. That's what we get when we plug in the 3. Now we subtract what we get when we plug in the negative 1. So that's 2 times a negative 1, that is cubed, minus 8 times a negative 1. Now just evaluate this. That's 27 doubled, so 54. Take away 24. Then we'll subtract from that. Negative 1 times 2 is negative 2, plus 8. I'm not great at math, but this looks like a 30 to me. And this looks like we're going to take away 6. I'm feeling a 24 coming. And if only there was a really convenient way to check my answer. Oh wait, there is. Just bust out your calculator again. Go right into y equals, and go 6x squared minus 8. You can hit graph if you want. It's a parabola. Doesn't matter. If we go second calc 7, it's going to do the work for us no matter what. So we're going from negative 1 to 3. So it's kind of a big chunk of negative area, but this positive area must be bigger because we're getting an overall positive answer of 24. So we're good again. We've done it right. All right, that didn't take so long. Let's do 4. All right, 4, my strong advice to you is if you're looking at a rational function, rewrite it as a power function by using a negative exponent. If you're looking at a radical, rewrite it as a power function by using an exponent that is a fraction. So this guy for sure wants to get rewritten. We'll still go from 4 to 9, but turn this root x into an x to the 1/2. And then because we're moving it from the denominator to the numerator, make it a negative 1/2. And this 1 isn't really doing anything. I'll write it, but he kind of has no bearing on the problem. But this is the form in which you should attack this function. Applying our rule, we add 1 to our existing exponent. That brings us up to positive 1/2. So you now have x to the positive 1/2. Now we had a coefficient of 1. We know we want to multiply by the reciprocal of our new exponent, so we're actually multiplying by 2 over 1. So our final antiderivative should be 2 times x to the 1/2. And I lied when I said our final antiderivative, because it should really be 2 root x. We want to turn that rational exponent back into a radical, because we started with a radical. But that's it. This guy's our antiderivative. So we want to evaluate that from 4 to 9. Notice they were very kind to you and picked 4 and 9, which are both perfect squares. So evaluating this should be easy. We literally just want to do 2 times the square root of 9. I'm doing this wrong. Not like super wrong, but 2 times the square root of 9. And then we'll subtract from that 2 times the square root of 4. So that's 3 times 2 makes 6. 2 times 2 make 4. I'm left with 2. But if you don't believe me, just pull out your calculator, and your calculator will say I'm right. So go to y equals and type in 1 over the square root of x. And then hit second calc, option 7, and let's integrate from 4 to 9. And we see this little skinny sliver of area that's just above the x-axis. And it says the area is 2, and we got 2, so we're good. What about 5? Okay, so 5's cool. For the 3 over x squared, we would rewrite that as 3 times x to the negative 2. The 1 is fine, obviously. We're still just integrating. I didn't actually do an antiderivative yet. I'm just rewriting the function. But now I'll do an antiderivative. And that means increasing the exponent by 1. So from negative 2, it goes up to negative 1. Then I'll keep my coefficient of 3, but I'll also multiply by the reciprocal of my new exponent. So that's technically negative 1 over 1. So this guy's antiderivative is going to just be negative 3x to the negative 1, which makes sense. If you differentiate that, you would get a positive 3x to the negative 2. So great, we did it. And the antiderivative of 1 should pretty obviously just be x. I'm not going to walk you guys through that. It's x. But there's our antiderivative. There's our capital F. So now fundamental theorem of calculus says evaluate that at the lower limit, negative 4. Evaluate that at the upper limit, negative 1. Subtract the results and you got yourself some area. So I guess I'm doing, oh, my bad. Probably on the quiz somewhere, I'll ask you to actually give me capital F. And if you're actually giving me capital F, make sure you take that guy and clean it up. So you better give it to me as 3 over x plus c. If I actually ask you to give me the antiderivative f of x, then clean everything up, right? No negative exponents, no fractions, and you'd have to include the plus c on the end. But if we're just working on this, trying to get to our final numerical answer, and you don't mind negative exponents, you can leave them, I guess. So I'm going to leave it for now while I do the work, confident that you guys know how to clean it up if you have to. But for over here, I'm looking at a negative 3, and we're going to plug in the upper limit of integration first. So it'll be negative 3 times negative 1 to the negative 1. Okay, then it's plus just negative 1. Then we plug in the negative 4 to get negative 3 times negative 4 to the negative 1 plus negative 4. So this will actually be just a scotch annoying to simplify and get rid of that calculator. But let's simplify it anyway. This negative 1 to the negative 1 would just be the reciprocal of negative 1, which is still negative 1. So this whole thing just comes out to 3, and then we're subtracting 1. So this whole guy's just going to be 2. Over here, things are a little uglier. This will be negative 3 times negative 1 over 4, so that'll be positive 3 over 4. And then we're subtracting 4 more from that. I'll go. I was toying with starting to simplify, but let's take it slow. So this is 3/4. Subtracting 4, well, that's 4 over 1. So times 4 over 4 would make 16/4. So I'm running out of space, so I'll work sort of side to side, but that's giving me a negative 13 over 4, but we're subtracting negative 13 over 4. And then just notice the 2 is over 1 as well. So since everything's fourths, we'd want to make this thing 8/4. And subtracting a negative means adding, which is telling me that our final answer is 21/4. And I feel moderately good with that answer. Why don't we go check the calculator, see if it's good. So we go to y equals, type in the function, which is parentheses 3 divided by x squared, close parentheses, plus 1. Second calc, option 7. My limits of integration are -4 to -1. Okay, could that possibly be 5.25? It could, because our answer was, if you forget, yoink, our answer was 21/4. See it right there, the 21/4. So 4 goes into 21 5 times, so you get a 5, with 1 left over. So it's definitely 5 1/4. Don't forget this is my least favorite notation, by the way. No mixed numbers. Mixed numbers are horrible. I'd actually prefer that you wrote 5.25. It's better than 5 1/4 at least. 21/4 is best. Give me 21/4 if you can. Alright, anyway, that's 5 down. Here's 6. 6 is another one involving trig, which I can totally do without making a mistake. So this time around, we're integrating, looking for that anti-derivative. And for 2, it should be a piece of cake. If you've been paying attention and practicing, then 2 becomes 2x. The derivative of 2x would be 2. Now, whose derivative could possibly be cosine? Is it sine? Yes, I think it is. So this is just sine. Derivative of sine is cosine. We want the negative, so it's not negative sine. We want just plain old sine. But we're good. This is our antiderivative. And we want to evaluate it from -pi/2 to 0. Notice they're keeping it pretty simple. If I ask you for the sine of pi/6, can you still do it? Can you do the sine of 7pi/3? Whatever it is. You better still have at least a little bit of knowledge about that kind of stuff in your back pocket. Although if the homework's keeping it simple, I'll try to keep it simple on the quiz as well. But let's do this. According to the fundamental theorem of calculus, in goes the 0. You got yourself a 2 times a 0 minus a sine of 0. Then you subtract from that 2 times -pi/2 minus the sine of -pi/2. So what is all this? 2 times 0 is 0. That's a no-brainer. Sine of 0, let me see. Unit circle. 0 is this guy here. Sine is y value. So if we're at the point 1, 0, then the sine is 0. So that whole first term, pretty boring. The second chunk over here. The 2's cancel. We get -pi. That's cool and all. Not pi over anything, just literally -pi. Then what's happening down here at -pi/2? Well, that's rotating us this way, so we're here. So our y value is -1. So this will be -pi minus -1. This is all 0. That's gone. So I now have -pi plus 1. Distribute the negative, and that's a positive pi minus 1. And that's probably how your final answer should stand, pi minus 1. I got a suspicion that pi minus 1 might just be 2.14159. So let's hit up our calculator and see if my suspicions are correct. Yoink. 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 Okay. So into the calculator goes the function 2 minus cosine x Oh, I didn't mean to do this many parentheses. 2 minus cosine x. That's perfect. Go calc, option 7, negative pi over 2 to 0. So that hunk of graph right there is 2.1415927. That is in fact pi minus 1. So yet another perfectly evaluated definite integral. Let's keep going on to 7. Turn this guy off. Okay, so this one says if the derivative of some function f is cosine and f of negative pi is 12, then f of 3 pi over 2 equals, well, I don't know. So if the derivative of this thing is cosine, this is going to really mess me up. Okay, the brain fog, man, the brain fog is real here. All right, so again, what's the deal? We've got some function f of x that we don't know a thing about, but we do know that if you were to do the derivative of f of x, you would get cosine. So again, if I did the derivative of f d dx, so if I did the derivative of f, I'd get f prime. That would seem to me then that the operation that gets me from f prime back to f would be integration, the antiderivative. So what's the antiderivative of cosine? Well, it's sine, right? Because the derivative of sine is cosine, so there's no need for a negative anywhere. What there is a need for, though, is a plus c, because this is not a definite integral. We are definitely just kind of doing an indefinite integral. So we still don't really know f. It's the sine of x, but plus c. So how can I evaluate f at 3 pi over 2 if I don't really know what c is? Well, we can figure out what c is, because they gave us this information. They said, yo, when you evaluate f at negative pi, you get 12. So we know that 12 is equal to the sine of x, or the sine of negative pi, I mean, plus c. So if I kind of completely solve this equation, I can figure out what c is. So this is 12 equals, what's the sine of negative pi? Isn't negative pi when you come halfway around the circle this way, and you're here, and sine is a y value? So that's literally just 0 plus c. So the 12 that they gave us, that 12 is c. So we now know that f of x, it's not sine of x plus c, it's literally the sine of x plus 12. So here's what just happened. We went from the general antiderivative, which had a plus c in it, to the specific antiderivative. We sort of found the value for c for this problem because they gave us a data point about our antiderivative that allowed us to pinpoint what c had to be in the context of this problem at least. So anyway, we're still not quite done because yay, it's great that we know what c is, but the whole point was we're supposed to be evaluating at 3 pi over 2. So let's now find f of 3 pi over 2 by simply substituting in 3 pi over 2, keeping our plus 12. Now 3 pi over 2, where is that? Isn't that 3/4 of a rotation in that direction, putting us here and giving us a y value of -1? So this is literally just -1 plus 12, which I can't help but think equals 11. That's it. The answer to 7 is 11. Product placement. Everybody go to 7-Eleven. All right, moving on. 8. Is this the same kind of deal? If the derivative of f is this function and f of 1 equals this number, then f of 4 equals what number? So yeah, this is the same basic function. So again, if you're being told that f prime is the sine of 3x plus e to the x, then they're asking you questions about plain old f, then what operation is going to get you from f prime to f? Well, you're going against the derivative. So you're anti-differentiating. So this is integration. So the integral of sine would be cosine, right? Well, no, it wouldn't be, because derivative of cosine is negative sine. So I need a negative on this. But there's another thing I need too, because this this expression in parentheses, that thing can't really change. But now when I differentiate this, I would have to chain rule out a factor of 3, right? So I need to kind of know that, and I need to incorporate a 1/3 here. So that now when I differentiate, I get my negative. I've got a negative already. Differentiating gives me negative sign. So I've got a negative to cancel the negative that comes from differentiating. I've also got a 1/3 to cancel this factor of 3 that pops out from the chain rule. So this is the most complicated derivative we've done so far, by far, because it does incorporate this chain rule stuff that we have to kind of balance out. But that's why I've always said that the best way to integrate is to just kind of make your best guess and then do the derivative of it and see if any craziness pops out. Like if there's a product rule, if there's chain rule, if there's some extra factor that comes from somewhere, then you can kind of just see what it is and respond. Like as soon as you see that you're going to pop out a factor of 3 because of chain rule, you just stick a 1/3 on it. And that's, to me, not so bad. But that's it. This is definitely the guy that would give us this. Now, who's the derivative of e to the x? Well, the derivative of e to the x is e to the x. So the antiderivative of e to the x must also be e to the x. I don't need to mess with that at all. That's good. But again, when I'm anti-differentiating like this, we should be landing on the general answer, which should still have a plus c on it. No, that's not going to help me evaluate at 4. So I have to take this piece of information they gave me first. And again, I know that if I evaluated this function at 1, then what I would get is 0.751, which means that negative 1/3 of the cosine of 3 times 1, that's just 3, plus e to the 1, that's just e, plus c. All right, so this is not something, I know I say I hate decimals, but these are some heavy decimals. There's definitely no way to express these because cosine of 3 is irrational. E is irrational. So you've got two infinite non-repeating decimals getting added together. So okay, fine. For once in my life, I'll waive my hatred of decimals because obviously there's really no way around it this time. But we've got this 0.751. Let's grab our calculator because nobody's doing this in their head. There he is. And there he is. All right, so I need some numbers here. It's going to be the cosine of 3. Oops. Cosine of 3 times 1/3, so divided by 3 is that number. But I want the opposite of that number, so times negative 1 will make it positive again. But then I want to add e to that. So plus e, who's a good e? It's not that one, right? That's just the letter e. Didn't they put e with no power somewhere weird? All right, whatever. I'll just use the weird one. I'll just say e to the 1. So unless I've screwed up, that should be the guy, 3048. .04828 plus c. So now I want to subtract that from the other number to actually get c. So if we did 0.751 minus our previous answer, then that number should be c. So negative 2.29, was it? 297. All right, so I accept that as our value of c. And that means that our specific antiderivative for f of x is that it's negative a third times the cosine of 3x plus e to the x plus negative blah blah blah, so it's minus 2.297. All right, now again, the whole point of the question was to actually evaluate this thing at 4. So plugging in 4, trying to find f of 4, we would get negative 1/3 times the cosine of 12, so that's irrational and ugly, plus e to the 4, that's irrational and ugly, minus this value of c that we found, which was irrational and ugly, 2.297. So just do your best, evaluate this thing, just chuck it into the calculator. And in the calculator, you're going to get negative a third as a coefficient on a cosine of 12 plus an e to the 4th. Can I say minus our previous answer? I can. So I better actually say plus and then do this, because it's going to bring in the negative automatically. But there's that whole expression. Boom, I'm getting 52.0196. So 019 is fine. Oops. 0196. Sure, I'm just going to do 4 decimal places because I don't love to have to round things up and say 020. That always feels bad to me. But that's what I'm getting. I'm not super confident how to check this answer. So I'll just check the other answer key and we can make sure that we agree. Okay, there's the answer, 52.0195. So we know we did it right. Feels pretty good. Let's go back and do more. That was only 8. We still have a lot more. 13, 12, 11, 10, 9. So let's just keep burning through these. I'd like to be done. It's getting a little bit late where I am. So what's this say? Let f be a differentiable function such that f of 1 equals 4 and f prime of x equals this expression. What's the value of this? This is the exact same thing we just did for 7 and 8. So let's do it again. Again, don't just be copying me, please. You just saw me do 2 examples. Now's a great time to hit pause and do this one yourself to make sure you really know what's going on. So you heard me, hit pause. Okay, great, you hit pause. So here's what I think the answer is. Again, if f prime of x is 6x squared plus 3, then for us to find f of x, then we need to do the integral of 6x squared plus 3. And of course that's going to be an x that is cubed with a coefficient of 2 on it. That'll be 6x squared plus a 3x. But technically with a plus c, again, because that's our general antiderivative. But again, they gave us a data point. They said that f of 1 gave 4. So if we substitute it into this, then f of 1 would be 2 times 1 cubed plus 3 times 1 plus c. That's supposed to give 4. But right now we're getting what? 2 plus 3 plus c equals 4. That means that 5 plus c equals 4. That means that c is obviously negative 1. So that means we can now take our general antiderivative and rewrite it as our specific antiderivative. Based on the context of this problem, we're getting a 2x cubed plus a 3x minus a 1. And that's the real f of x for this problem. And all we got to do now is find f of 3. So f of 3 is nothing more than 2 times the 3 that is cubed plus a 3 times the 3 minus a 1. That's a 27 doubled, which is still 54. That's a 9. Minus 1. That is a 63 minus 1. I think where I come from, we call that the number 62. So final answer should be 62. Don't believe me? We can double check. We can double check, can't we? 62. Okay. Next. All right, let this be a differentiable function. What is the value of dabba-do? All right, whatever. Same thing again, it looks like. Although, what does this mean? EX? Do you think they meant E to the X, or do you think they just made a typo? I can check the answer key and see. No, I don't. I don't know what they meant. It doesn't really say. I might have to play with this one to see what they meant, if they meant E to the X. They probably did, but yeah, let me go mess with it and see what I can see. Okay, I am back from my farting around. And after looking at the answer key and seeing what answer they're arriving at, I know that there's no typo here. They're just kind of being weird, and they're just asking you for the cosine of x with a coefficient of that irrational number e. So it's literally just e times x, where e is 2.71 blah blah blah, 2.718, right? So it's that number e. So that's fine. We can handle this. I feel really confident in our abilities. So again, if f prime is the 2 minus the cosine of e times x, then our antiderivative must be 2x. And then it's minus cosine. Antiderivative of cosine is sine. And then I wouldn't mess with these insides. I'd leave it as e to the x. Derivative of cosine is sine. So yep, everything's hunky-dory. There's no negative signs to worry about, but there is going to be a factor of 1 over e. No, sorry. There'll be a factor of e that pops out by chain rule. So we need to insert a 1 over e, so that now when we differentiate this, and it would become 1 over e times the cosine of e to the x, then would chain rule out a factor of e, which would cancel with that, and everything would be great. So there's our antiderivative. Except don't forget the plus c. So plus c. And again, that means that this is our general antiderivative. We can get to our specific antiderivative by finding the value of c that makes everything work. And they gave us what I think is going to be a fairly easy one, since they told us that f of 0 was 0.5, negative 0.5. That means 2 times 0, that whole term goes away, minus 1 over e times the sine of 0 plus c. This whole thing should just be negative 0.5. So that's a 0. We can cancel it. Now the sine of 0, sine is a y value, so sine of 0 is 0. So that whole term, we can cancel it. And there you go. C literally just is negative 0.5. So that means our specific solution for this problem, for f of x, is that it's 2x minus 1 over e times the sine of e times x minus 0.5. And now we're supposed to find f of negative 2. So to find f of negative 2, just substitute that in, and you've got 2 times negative 2 minus 1 over e times the sine of e times negative 2. So this is not e minus 2, it's e times negative 2, minus 0.5. And I'm going to let the calculator do this whole thing, I think, because it's going to be ugly. Well, am I? Yes, I am. Because it's going to be pretty ugly. So if I just mush all this into the calculator, then I'll be looking at a little something I like to call negative 4 minus 1 over e. Let me put that in parentheses. And this is the E I meant, by the way. You guys probably knew that and were yelling at me again, but that's okay. Sine of negative 2e. That's this guy. And then minus 0.5. That's everything, right? Entered correctly. Negative 4 minus 1 over e sine of... Yeah, okay. Seems good to me. Press enter. Get a number. Negative 4.775558. So negative 4.776 is great by me. Alright, so there it is. Again, there's no great way to express this answer exactly. If you were gonna, what would it be? This is negative 4. Take away another half, so it would be negative 4.5. Then it would be minus the sine of negative 2e all over e. Just to be annoying, sure, I'll keep going. 4/5, that's 9 halves, right? Which would be 9e over 2e if we wanted to get a common denominator. So this would be negative 9e minus the sine of negative 2e all over... Oh no, I need a 2 over... Okay, no. You guys can't even see what I was doing because it was behind the dumb old calculator. But luckily, I was really just trying to demonstrate that trying to give the exact value, trying to get the exact expression here, just more trouble than it's worth. So I'm fine. The decimal's fine. Again, I'll make it really clear on the quiz when you must be exact and when you can give a decimal approximation. So no worries there. That's 10. We've still got an 11, 12, and 13, and we're creeping up on an hour long in this video. So let's keep rolling. This says, let h of x be an antiderivative of 5 minus 3x. If this is true, then what is that? This is the same question again. Let h of x be an antiderivative of that thing. Sure. So an antiderivative of that essentially just means that that's the thing we're doing the integral of. So 5 minus 3x dx. If we do the antiderivative of this, we get 5x minus 3 halves x squared, but with a plus c on it. And so this is now h of x. And again, we know that h of negative 1 is giving negative 3. So that means 5 times negative 1 minus 3 halves times negative 1 squared plus c has to give us negative 3. So this is a negative 5 minus 3 halves plus c equals negative 3. So what is this? This would be negative 5 and 3 halves, aka 10, 11, 12, 13 halves. So blah, blah, blah. C is therefore going to be negative 3 plus those 13 halves, which of course is negative 6 halves plus 13 halves, which is positive 7 halves, aka 3.5. But 7 halves is C. That means we can now take this general solution and make it our specific solution. So we now know that h of x is 5x minus 3 halves x squared. And then instead of plus 3, we can say plus 7 halves. And that means if we want to find h of 2, then we just plug in 2. And we get 5 times 2 minus 3 halves times 2 squared minus 7 halves, which, if we start to simplify, is going to be 10 minus, this guy squared is 4, and 2 goes into 4 2 times, and 3 times 2 makes 6, minus 7 halves. So 10 minus 6 is 4, aka 8 halves minus 7 halves. Seems to leave us with only 1 half. So the final answer to the question is this thing here. This is what h of 2 is. Remember, this guy down here was just what the plus c was, so we don't really care about that anymore. But that's the answer for 11. Are these going to get more interesting, or is it going to be more of the same? So this one says use your calculator and let f of x be an antiderivative of this thing if f of 2. Yeah, this is just more of the same. I am getting bored of this, so you guys must be too. But yeah, to find f, they're literally telling you it's an antiderivative of the ln of x over x dx. And they're telling us we can use our calculator, but even still, I just want to cancel this one because I told you guys we weren't going to deal with any natural logs. So if you are going to do this by hand, you don't know how to integrate natural logs. So let's just like not do it. So 12 is out. Let's do 13. I wanted to include 13 because I wanted to include a piecewise, but I wonder if I'm regretting my decision. I don't think I am. So how's a piecewise go? X minus 1 only to the left of 0 means we'd have a y-intercept at -1. Oops, but we can't include it. So you'd actually have a hole down there at -1. And your slope was +1, so we'd go left 1, down 1, left 1, down 1. So you got an increasing line. So slope line of slope 1 hits here. Then sine takes over. And sine likes to start at the origin. So he's going to be here. And he's going to do the old loop. All right. So you are now supposed to integrate from -1, that's like here-ish, all the way out to pi. Pi would be right here. It's where the sine function is 0 again. So you'd want this trapezoidal hunk of area, then you'd want this area that is under the sine function. Now if you're allowed to just put this into your calculator, well, how would you? You can't enter piecewise functions, can you? So after sketching this out, you'd kind of have to realize, I wish I had color-coded this a bit better, but why don't we say this first hunk of area is lavender? Why don't we say this second hunk of area is a nice burnt sienna? You'd basically have to break this down and express it as two separate integrals, right? The first integral for this lavender interval would go from -1 to 0. And we're obviously looking for the area under the line, so it would only be the x minus 1 dx. Then we would add to that the integral that goes from 0 to pi, and we only want the area that's under the sine function, so we'd only want that. So basically, to integrate h of x, if h of x is a piecewise function, you'd kind of necessarily have to break it down to two separate integrals, right? So I'm liking this question, actually. This seems like a good question for me to put on the quiz, where maybe we define some piecewise function. You have to think about your the intervals on which the different functions are active. So if you're integrating from -1 to 0, then of course you're going to be using the top function, because it says that's where we are less than 0. Anyway, blah, blah, blah. So could you do this by hand? Yes. Could you do this on a calculator? Yes. Do you need to be able to do both? Yes. So why don't I do it by hand, and then we can double check with the calculator. But this antiderivative should be feeling like a piece of cake by now. This would be an x squared with a coefficient of 1/2. And -1 is just minus x. Then you'd want to evaluate that from -1 to 0. Why did I color code this? I'm not color coding anything. Maybe it's a little late now, but this is the lavender piece. You guys are with me on that, right? The burnt sienna piece is over here, which of course means everything that I just wrote in burnt sienna should actually be lavender. Great. All right. Now plus sign. And then all this burnt sienna stuff. The antiderivative of sine is not cosine, because the derivative of cosine is negative sine. So the antiderivative of sine is negative cosine, and we're going to evaluate that from 0 to pi. Yoink, yoink, yoink. All right, I'm going to do this a little fast because obviously plugging in 0 is going to give 0 minus 0. Then we're going to subtract from that the negative 1, which gives positive 1. Half of that is positive, a half. And then minus negative 1 is plus 1. Now all that's in parentheses though. So this will be, we're subtracting 3 halves, so we're getting negative 3 halves. Then the cosine one, this will be the opposite of the cosine of pi minus the opposite of the cosine of 0. And again, who's who? We still kind of need to just draw this out, but pi puts me over here. Cosine is x, so this is the opposite of a negative 1. Then we're subtracting from that the opposite of cosine of 0. That's a positive 1. So that's a lot of pluses and minuses and 1s and stuff, but what does this come out to? That's a 1 plus 1. That's a 2, so it's negative 3 halves plus 2, which is of course negative 3 halves plus 4 halves, which is just a half, exactly a half. Okay, if you say so. Just to be sure, does the other answer key agree with me? It does, so it is just 0.5. Okay, great. And we could have put that in our calculator to verify actually, but now I don't want to because the video's over an hour already, so let's just be done. All right, I hope you appreciated the last video you'll ever get from little old me. See you on Monday. Bye.